Now, if you want to absolutely bulletproof this, you can just say this. If anything happens, any possible exception, then just set double value to 0. And so you can look at this previous slide, actually a couple of slides back. Exception class is at the very top of this hierarchy of available exceptions, at least this particular subclass of exceptions that we deal with in our current code, is that you can use it, but it's not advisable to use it like this, because perhaps you could say, let me give you another example. You could actually give user some information, system system.out.print print line, and print something, really. Just say unexpected condition, setting value to 0, something like that. I don't know how much sense it makes, but it sort of like tries to mimic the reality that is taking place. Now, however, you may be trying to do this. On any occasion because you just want to say, no way I would like to allow this code to crash, right? Under no circumstances I want to allow this parse double to crash. However, this exception will overshadow the condition that we used previously. Right here, there was a number format exception that we were experiencing as a result of this. So perhaps a better code would be to do this. Just to say, well, you know what? We would like to catch this particular exception, number format exception, and deal with it right here in this catch block, and deal with it separately, and say this is a number format exception. Number format exception occurred. Okay, that's a possibility. Otherwise, you want to say, well, I still don't want this program crash if something else happens, and so I will be printing this other message. So the try statement can have multiple catch blocks, and those multiple catch blocks will be specifying different exceptions. If we observe the hierarchy of objects in this exception hierarchy, then you should start with the lowest possible exceptional conditions that you would like to catch. Because if you still want to catch the exception, which basically covers any possible situation, you need to keep it low on the list of catch blocks, because if you put it at the top, if this was placed at the top, somewhere here, so if I placed exception at the top, now earlier versions of compilers would actually allow this to compile, but you would never catch this, because if exception is at the top of the hierarchy, it will be caught right here, because this is the most abstract level, and never allow it to go down here. The current version of the compiler actually realizes it to be an unreachable code. So let me compile this and see what kind of error I get in the situation. I'll try to build it and see what error. Exception, number format exception has already been caught. So the error that I got in this situation is that this particular catch statement already catches all kinds of exceptions, because exception happens to be at the top of this hierarchy. And so if you said you want this exception, it will catch any situation, including this. And so this becomes otherwise unreachable statement because exception was already caught. So we really need to structure our exception handling code in this manner that more specific exceptions occur at the top, the less specific exception appear at the bottom of this try and catch statement. So there's some technicality to this. There's some more coding to this, but it really isn't that different than any other statements. So let me demonstrate it one more time with this illustration. All right. So perhaps what I can do here is just go to like blank screen. So again, main is invoked. It has its own local scope of variables. It is trying to call another method called getUserInput, which organizes its own local scope of variables so that it can have its own local parameters. And eventually, upon return, what happens is that this frame here, this location of local variables that belong to getUserInput collapses. And I return back to my main method right here, and I continue the execution. Okay, but let me review this one more time. What happens before getUserInput return? So this is getUserInput, and this is main. Okay, so just before this method returns, and I'm actually trying to visualize the local scope of variables, the scope of local variables on this program stack. What happens is that at some point it contains this value, the local variable named temp, in my case, which actually is returned back to main, right? This is, under normal circumstances, what's taking place. We say return the value. We already got this value. Supposedly, I didn't have a try and catch, and there was a possibility that input mismatch exception will be taking place as a result of scanner next double. Suppose that there was no try and catch, which was our first version of this method. This was the very first method. We never had try and catch. We still were able to get proper inputs from the user, until they type garbage. Okay, so what happens if we don't have try and catch in that early version? What happens is that, in a way, the try and catch, which potentially could be looking exactly like this, what happens is that the input mismatch exception object is manufactured someplace in memory, and instead of returning this temporary variable, upon return, the getUserInput, what it does, it returns not this, but this, right? So, but it's a different return mechanism. It's an alternative return mechanism because we say that we can interpret this return if we have a catch statement. And the catch statement, when main says catch someplace here, there's a catch statement in this main method. This is just a memory that it operates, but this is the actual method in memory with executable statements. So then the catch statement right here gets access to this exception object, which was originally manufactured by, within our getUserInput call. So really, if you compare try and catch a construct, it's really an alternative to a method call and method return and returning a value. But in this case, you're receiving an exception object, which you have a chance to reference, just like this, and even work with it internally. Like, for example, right here I could say exception. There is a method to say print stack trace. I could just print the stack trace as a result of this on the standard output device, on the essentially sending it to system out device. All right. So that's the nature of exceptions, and exceptions truly alternate the flow of control, because what's interesting when we look at our code is that if we never handle exception, then our execution terminates on the statement if we didn't have a try and catch. If we do have try and catch in place, then the flow of control still terminates on this line, and we resurface right here. Because if we catch this exception, then we resurface right here, and the execution continues. So clearly, this is an alternative flow of control within our executable code. So that's the nature of the exception mechanism.